Hello, this is Mr. G Math coming at you live. We are live. Isn't that right? Isn't that how American Idol starts?
No, it's iCarly. It's like 5.
I thought American Idol. I thought that's what Ryan Seacrest says. Didn't he say that? We're coming at you live. All right, let's go through some of these real basic algebra concepts quickly, because you know this, but some might be new to you. So, we've talked already that you understand the concept of slope and calculus are really important. So, the slope of a line, there are different ways to describe it. You know this already. Rise of a run, y2 minus y1, x2 minus x1, the change in y over the change in x. If you look off the graph, can you find that slope for me? So do that quickly. I know everyone can do it. So for number 1, in your packet, answer it. These are your notes as well as other notes attached to it. But a lot of notes are going to be right here in the packet I gave you. So if I asked you, does that line have a positive or negative slope? Negative. Why? How do you know? It's decreasing, right? So when a line is decreasing, it has a negative slope. Yes, here. What is the fall and what's the run? It goes down how many and to the right how many? Or you can go up and to the left, either way. So 1, 2, 3, down 4 and to the right 3. If you counted up and to the left, you would get the same answer. It doesn't matter if the negative's on top, the negative on the bottom, or the negative in front. What does matter is that they're not both negative. It's not negative 4 over negative 3. All right, how would I find the slope if you don't have a graph? What is it? How did y change? What did the y coordinate start at? 0. What did it end with? So how did it change? It went up by, look at the x. What did x start at? Negative 2. What did x end with? Did it increase or decrease? By how many? Let it go. 3. Rise over run. The y, how did the y increase? 2 to 2. It didn't at all, right? It stayed the same, so it's 0. And how about the x? Does it really matter? It would only really matter if the points were exactly the same. Then it would be instantaneous, and it would be an indeterminate, right? It wouldn't have 2 points then, right? But 0 divided by any number other than 0 is 0. Last one. What is the slope between those points? The change in y is 3. The change in x is 0. So what do we say this slope is? Those 2 points make a special line. Those 2 points make a vertical line. And a vertical line has a slope that is undefined. A horizontal line has a slope that is 0. Try again, right? This is all on video, man. Horizontal line, slope is 0. Vertical line, slope is undefined. Do you see, if you turn your heads back there, there's a cute little blue poster and a cute little yellow poster in the bottom left there? Blue and yellow right beside each other. Yeah. One says vertical line. What does it say underneath there?
X equals A numbers.
Right? Does it talk about the slope? Oh, there's one about slope up there. That's like an orange. And there might be something there to do with the 0 compared to undefined. I thought I had something up there to do with that. No?
Yeah.
No. I'll have to make some. Talks about. So horizontal has what type of slope? 0. Vertical has what type of slope? Undefined. Parallel. What does it mean when 2 lines are parallel? Slopes are the same. Perpendicular. What's true about the slopes? I like that. Some people say negative reciprocal or opposite reciprocal. Both are good. So what's true about perpendicular lines is that they meet at a certain angle, and that angle is 90. So notice one slope is 5 over 2. The perpendicular one would be the opposite sign and reciprocal. So what are different types of equations of lines we can use? Do you see these 3 right here?
Yeah.
We're going to add one to that. Which one are we going to add that's not here? HK form. Let's write that down. What is the least popular, useful one is the general form, right? So HK form would be y equals m x subtract h plus k. And the reason the HK form, it might be more powerful because we can use that for so many functions, right? Especially polynomials. If I put a square on the parentheses, now that's like a parabola, right? In terms of or if I put a cube on it and so on. Okay, how would you find an equation of a line described each way? What's an equation of a line through a point and a slope? How would you write it down? What form would you pick? Either HK or point slope. If I went HK, what would the equation look like? What's the slope? What's the x coordinate? Change the sign. So it's x subtract 2. And what's k? And that's on the outside. If you had to, which you don't, but if you had to, quickly change that to slope-intercept form. Could you distribute combined-like terms and easily change the form? Like often in a multiple choice exam, you can't pick it. Like they pick it for you, right? So could you quickly change that to match one of the answer choices? Yeah. If that was free response, any of the forms would give you full credit and you'd let it go. It's only in multiple choice that you have to see, oh, there's different ways it could look. Because then you don't know how to match the answer to it. 6, vertical line through that. What's the form of a vertical line? Now you can look at that blue and yellow poster. What's the form of a vertical line? What does it look like? On the bottom left. X equals a number. What does x equal in this case? -1. So x equals -1. That's the form of a vertical line, and it goes through that point because the x coordinate is -1. 7, a line through that point but parallel to that. So what does the word parallel mean? Same slope. Can you know what the slope is when it's in this form? No. You might be able to have a little formula, but honestly, do you remember what the slope is? Just looking at it. So what do I need to do to find the slope? Yeah, right? To write it as a function, right? To write it as mx plus b. What would be the algebra to get y by itself? Subtract 2x. Does it combine with the 5, or do they go beside each other? And then how would you get y by itself? Now, when you divide by -5, I don't really care about the y-intercept at the end, right? What's the only number I care about? And -2 over -5, what's the slope? And it stays the same slope, right? Why? Because it's parallel. What point are we using? -1 and 2. How would I write that as an equation? I would write down what? Y equals, what would you write down? 2 over 5, x plus 1, and then what? The more you practice, this skill shows up a billion times over in calculus. Can you quickly write an equation of a line? It's not that bad, right? If you practice, can you see that pattern? To write it. We're going to do it again. Again, we have a point. This time it's perpendicular. What happened? Yes. Oh, did it say write it in slope-intercept form? Boo, right? So, I don't like fractions. Do you like fractions? Just kidding. I love fractions. So, 2 over 5 times x is 2 over 5 times x. And then it's 2 over 5 times 1, right? That would be what? 2 over... And then what do I have to add to it? That's really complicated. That's it. So what's 2 over 5 plus 2? 2 and 2/5, right? They just go together. Isn't that sweet? Little mixed number. Do you have to write it as 12 over 5? No. It's nice if you see 12 over 5. Do you see 12 over 5? 5 times 2 is 10, and 2 more is 12 over 5. All right, 8. Perpendicular. What does that mean? No, it means the opposite reciprocal, right? They meet at 90 degrees. Do you notice the equation is exactly the same? What slope did we use when it was parallel? So that means, do you know the symbol for perpendicular is an upside down T? Did you know that? Nice. What's the sign that's opposite of positive 2/5? Negative, and the reciprocal would be 5/2. How would I write this as an equation? Let's start with HK form. Negative 5/2. Then what would I write down? X plus 1. Then plus 2. Now, if I wanted to write it in general form, which seems kind of silly, but I'll do it because they said so, I'm going to distribute. If I distribute, well, because it's in general form, one of the properties of general form is that all the coefficients have to be integers. And because of that, it would actually be easier to multiply everything times 2 first. So if I multiply the left side by 2, it's 2y. If I multiply the right side, the 2's divide out, and you're just left with negative 5. And then you can go negative 5 times x, negative 5 times 1. And then 2 times 2 is 4. So if I put this in general form, sometimes it's called standard form, add 5x to the left side. So you have 5x plus 2y, and then combine like terms, and negative 5 plus 4 is negative 1. It's just testing your algebra memory, right, in terms of what you'd need. Do you know how to draw a line? How would you graph the line 2x plus 3y equals 9? Most of you would write it as a function, right? You would subtract 2x and then divide everything by. Now, negative 2 divided by 3 is a fraction. 9 divided by 3 is just 3. How do I take that equation and put it on the graph? Where would I go to first? And what's the y-intercept? So start at 3. And then what direction do you go from 3? Down 2 and to the right 3, and then you have your line. What does the line y equals 2 look like?
Just horizontal.
It's horizontal at what number?
2.
So at positive 2, what would you draw? A horizontal line. Turn the page. So, number 11, I want you to type that function into Desmos. Remember we talked about when we have calculator examples what we're going to do? So, you won't actually see this on the video. Desmos.
So it shows what you're writing.
You'll just hear my melodious voice.
Oh, cute.
But you'll still see the screen that you see up on there. Well, you actually don't even see it. It only is what's on the hover cam. So if I pointed the hover cam to Desmos, I guess it would do it then. So right now you're just hearing my voice. So can you type that in? What would be a good window to be able to see all the things you need to? So first you're going to type in negative 0.2. Do you need the 0 in front? No. X cubed. Subtract 2.2 x squared plus 1.6 x plus 1. So there's the equation. You could also, with Desmos, they don't even care if you put y equals at the beginning. But if you do put y equals, it gives you more points that are significant. So can you type it in? What would be a good window to see everything you need to see? So when I look at that window, what do you think the function is? When you look at the equation, what do you think it is?
Cubic.
So do you think you see everything you need in that window? No. So can you press the minus sign? And then what do you notice? There's more to the graph, right? What happened? Huh?
It just popped out of nowhere.
Nowhere, right? So do I still see everything I need to? And here's the answer. You have to be able to see every turning point. Do you think you see every point where the graph turns yet? No. So again, I'm going to press a minus sign. Do you think that window would allow us to see all the significant points? Right? Do you see the end behavior? Do you see where it turns? Do you see the intercepts? Right? All those things. So what window would give you a good picture then? Well, what window for the x do you think? From left to right, what should the window be? What is the x coordinate here? Negative 11. So a good window would be to the left of that, right? So like negative 20 would be an okay window. Negative 15, right? And I like to keep my windows symmetric if I can. What does that mean? If it's negative 15 on the left, I like it to be positive 15 on the right because it gives me a better view of the picture when it's symmetric. What do you think the y value should be? How high and how low? Well, how low is this turning point, the y coordinate? So it has to be at least below that, right? So like negative 55, and then you can go all the way up to positive 55. And then could you draw the picture of what it would look like in the box off of Desmos?
From 20 to 20.
So you're just sketching. Could you sketch what the picture would look like? See how I did that? So from left to right and from bottom to top, that would be a window where you would see the turning points, you would see all the intercepts, and could you sketch, right, what that equation looks like? Unfortunately or fortunately in calculus, they love giving equations that look intimidating, that you have to have the courage to type it in and manipulate the window until you see what you need to. When you actually look at the picture, the equation doesn't look that bad, correct?
Yeah.
But at first it kind of looked bad. Can we try for 12? Can you find the zeros? And we're going to use Desmos. And the N92 Inspire, that's what you're getting, the CAS N92 Inspire. It's inspiring. I think it might even be in color. And a lot of features you see on Desmos you would see on this calculator. So the whole idea is to try to make things quicker and easier to access, right? What are the information you need? So, and I have myself, it'll be new for me. So it'll be us together learning too. So that'll be fun. So 12. What would the zeros be using Desmos? Could you do that? So I'm going to go back to Desmos. I'm going to cross out of here. I'm going to type in. Oh, is it the same equation? Oh, I feel silly. Oh, undo. Oh, I feel good. I can undo it. So where are the X intercepts? And there's 3 of them. And in calculus, we're going to constantly remind ourselves to round to 3 decimal places unless you're told otherwise. Okay, Candy? We got this? Did you write them down? Now, how would you write zeros properly? So 1 0 is at negative 11.65. Another one is at negative 0.406. And another one is at 1.056. It's important that you write them down as points because that's what they are. The worst way you could write them is to say x equals, x equals, x equals. And why is that bad? That's right. When you go x equals a number, you didn't say an intercept. What you did was describe a vertical line. Keep going. 13. Find the points of intersection of those two. I am so still recording. But that microphone can pick up like what Andrea's saying over in the back corner. So it's a powerful little mic. So be careful what you're saying to Joe. It'll pick it up. You go, isn't this lame? You totally would pick it up, Andrea. All right, this one I am going to erase. So it's two different equations. Now, I'm going to tell you that I think even for our calculator, that you're going to have to learn how to write it as a function. So the first one you can type in as is, but for the second one, I don't think Desmos cares, but I care. You have to write it in the form y equals for the second one. And again, I don't think Desmos cares, but I care because graphing calculators want you to write it as a function. So the first one is written as a function. What do I mean by that? That y is by itself and everything else is on the other side. That's how you write it as a function. So the first one is written as a function. Can you tell me quickly how I can take the second equation and get y by itself? Just add y. And if you add y, what does y equal? 3x plus 5. Beautiful. Good algebra. Can you tell me where they intersect? At what points? Point requires an x and y coordinate. And again, we're going to round to 3 decimal places. So negative 1.046 and 1.862. And the other point is at .0, oh, I wrote it wrong, is at .615 and 6.846. When we get our new calculators to know how to graph, find points of intersection, intercepts, all those things, we'll have to be able to make sure we know.
Mr. Goodson?
Hey!
This might seem like a dumb question, but for the calculus exam, would we be able to use those calculators?
Yes. In fact, when we get closer, in fact, I already know the date for the 2018 one. I looked it up yesterday thinking, is it already up? It's up. All the AP exam dates are already up. And that's a serious conversation for all of us that are in AP Bio, in AP English, and AP Government, and all that. Do you realize what that 2 weeks is going to look like before you even start the school year, right? And some of you are going to have to make a choice. Like this year, the seniors had to take calculus in the morning, and they took Spanish or French in the afternoon. Both were offered at the same time. That's going to be the same for next year. They did not change that for 2018. Calculus in the morning, Spanish or French in the afternoon. So if you're taking Spanish or French, right? So are some of you taking AP Biology? If you're taking AP Biology next year, AP Biology is Monday morning. Tuesday morning is calculus. Tuesday afternoon is Spanish. So there's at least 12 students this year in calculus that had that schedule. Let alone the week before taking AP English, AP Government, AP Psychology. All of that was the week before. So if you want to look at the AP schedule, but it's not saying that you should drop any of those AP classes. It's just to know ahead of time. And then you think that you're going to be in a musical, right? Or you think that you're going to be on a sports team in spring. Or you think you're going to be wherever else while you're trying to prepare, right, to pass all these AP exams and realize those 2 weeks in May, how intense they are. You can't go to 4 hours of sleep, right? You can't average 4 hours of sleep that night and pass this. You're going to pass out. Anyways, that's my rant. So, how can you use a calculator? Hey, how can you use a calculator to solve that inequality? Do you know what you do? So first, you put in the absolute value of x squared minus 5. So type that into Desmos. Oh, what happened? Then, isn't that fun? Didn't that look like what I gave you the other day? Do you remember? That was one of my PDFs where you had to do the derivative of that. Thank you. Now, you say, wait a second, isn't there a 4 there somewhere? Well, guess what the second one's going to be?
Wait, isn't it?
One side is x squared minus 5, right? And the other one is just what? 4. And the question is, at what x values is the above graph bigger than the below graph. So when is x squared minus 5 bigger than 4? Do you get the idea? So do you see the line here? Guess what point's going to be important? Where they intersect. So where is the purple above the black? So first of all, one of the answers in an interval notation would be from negative infinity to, what's the x value there? Negative 3. What's the other one? From negative 1 to 1. Now make sure you use brackets because there's an equal part to the arrow, right? So it's greater than or equal to. I'll show you the answer in a second on the packet. And then what's the last area where the purple is above the black line? From positive 1 to infinity. So if I looked at the screen, do you see the black line, the negative 3? And do you see the absolute value of x squared minus whatever it was, 4 or whatever, right? 5? Okay, where is the purple above the black? From negative infinity to what number? Negative 3. Where else is it above? From negative 1 to positive 1. Where else is it above? From 3 to infinity. How would I write that in interval notation? So let me show you the answer. And there it is. Can you see? From negative infinity to negative 3? That just means the union. That means that the answers are connected, like the word and. Negative infinity to negative 3, and. And it's like a U, meaning union. They're together. Negative 1 to positive 1, and they're included. That is the symbol U, like union. But we can use the word and there too. So what's the solution? From negative infinity to negative 3, and negative 1 to positive 1, and 1 to infinity. Those are all intervals where the absolute value is above the horizontal line that we can use a graphing calculator and graph something to solve something instead of solving it analytically. Beautiful. First video.